Okay, first thing we're going to be looking at today is a little bit of a definition. And that's regular polygon. Okay, there's two things that make a polygon regular. And that's that all sides are equal and that all angles are equal. So think about a square. A square, all the sides are equal and all the angles are equal. Therefore, a square is a regular polygon. But now let's think about a rectangle. A rectangle seems like a normal shape. It's one of the first shapes we always learn. Okay, but here, all the angles are the same, so that's good. But the two across from each other are the same, but the other two are different. So all four sides are not equal. Therefore, a rectangle is not a regular polygon. Any shape that doesn't have all equal sides and all equal angles is an irregular polygon. Okay, now we need to talk about what interior angles are. Okay, interior angles are just the angles inside whatever shape you have. Now you can see here we have a regular triangle because this triangle, all three sides are equal. So that makes it an equilateral triangle, which we know means all three angles are equal as well. So it's a regular triangle. Okay, but if we're talking about interior angles, then we're talking about all these angles on the inside of the shape. Okay, so interior angles are all the angles on the inside of the shape. Now, as I've noted here, yes, in a regular polygon, those are all equal. Because in a regular polygon, all the interior angles are the same. Now, we've already dealt a little bit with interior angles with a triangle. We found out that the sum of all the interior angles of a triangle is 180. Remember we did that earlier? We added all of them up, and they always equal 180. Okay, so that was our first introduction to interior angles, and we found the sum of interior angles of a triangle is 180 degrees. Well, now we're going to look at interior angles of other polygons. Okay, so I want you to draw a square. Okay, it should look like this. Now I want you to draw as many lines connecting two different corners as possible. Except you can't have any of your lines cross another one of your lines. Okay, so if you draw one and it crosses another one of your lines, then you can't draw that line. Okay. So, you have one? Alright, there's pretty much only one option. It's one line straight across the middle like that. Now, yes, you could have drawn from this corner to this corner, but still that's pretty much the same thing as if I turn my square, that's what I'd have. Okay, so all you can do is from one corner across to the other. That's called a diagonal. Okay, because if I try to draw the other one this way, it's going to cross that one. Okay, or if I try to connect these two, that's already the side of my square. So that doesn't add anything. Or connect these two, that's the side, that's the side. Okay, so the only thing I can do is draw one line across the middle. Now, why did I do that? Well, to look at interior angles. We may not know what a four-sided figure has for interior angles, but we do know what a three-sided figure has. Right? And any four-sided figure can be divided into two triangles. Okay, now that's not just a square. That's not just a rectangle. That's anything that has four sides. Okay? If it's got four sides, you can draw from one corner to the opposite corner and cut it into two triangles, no matter how weird the shape happens to be. Okay? So, now what do we know about these two triangles? Well, the interior angles all add up to 180. So that means we have 180 degrees in this triangle, and we have 180 degrees in that triangle. So what does that tell you that we have in the square? That tells me that we have a sum of interior angles equaling 360, because 180 plus 180 is 360. Now, let me go back to my directions here. This is why we couldn't cross any lines. Because if we crossed lines, then you created angles that were not on your original shape. See, every angle in these two triangles is on my square. Right? If I drew a line across here and these crossed, then there would be angles in here that weren't touching my square. So I don't need any angles that aren't touching my square. That's why the lines can't cross. Okay, so one corner across to another corner, as many as you can do without crossing any lines. Okay, and then you can see all you'll have left is triangles, and that's 180, that's 180, so the sum is 360. So any four-sided figure, the angles add up to 360 degrees. Okay, now I want you to follow the same procedure that we just did on all of these shapes. Okay, so we've got a triangle or a three-sided polygon, a square, four-sided, pentagon, five-sided, hexagon, six-sided. See if you can draw the lines across these shapes. Okay, well, the triangle, as you can see, there's not any lines you can draw. Any line you draw from one corner to the other is just one of the lines of the triangle. So there's no way to divide that up because it already is a triangle. Okay, so there's only one triangle in a triangle. All right, with the square, we just saw that. Okay. Oh. Yeah, so that's one triangle is 180 degrees. Alright, so the squares we just saw, only thing we can do is cut it in half. And we get a triangle and a triangle. That's two triangles. So that's 360 degrees, because each of these is 180 degrees. That makes 360 when I put them together. Okay. Now, the pentagon, could be a couple of different ways you could do this, but this is the way I'm going to show you. Just out and out. Okay, now you could have had your line go across and then down to this side or whatever, but either way, as long as you didn't cross any lines, you end up with 1, 2, 3 triangles. Okay, and since triangles are 180 apiece, That makes 540 degrees. And the same thing with the hexagon. I'm just drawing my lines out until I don't have any more corners to go to. And I see that I have 4 triangles. Okay, which at 180 apiece is 720 degrees inside of a hexagon. Now the question I have to ask you is how many triangles are in not just each of these shapes, but every shape. Okay, how many triangles are in a polygon? Well, let's look at the triangle. Okay, first I'm going to note that it has 3 sides. And how many triangles did it have? It had 1 triangle. Okay, then the square, it had 4 sides. And it had 2 triangles. The pentagon had 5 sides and 3 triangles. Are you noticing a pattern here? The hexagon had 6 sides and 4 triangles. So how do you know how many triangles are going to be in a shape? Okay, well, it's always just the number of sides minus 2. See? 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. The number of triangles that fits in that shape is always 2 less than the number of sides every single time. Okay, and we know that each triangle is 180 degrees. So interior angles, and here's our formula, is n minus 2 times 180 degrees. Okay, and this is where n is the number of sides. Okay, so what you do to find the total, the sum of interior angles, is you do the number of sides minus 2 and then multiply that by 180. See, if I do that here, this has 6 sides. 6 minus 2 is 4. And 4 times 180 is 720. Works every time. And it works whether it's a regular or irregular polygon. Alright, so now we're going to try to find the interior angles, or more specifically, the sum of interior angles. Okay, so here's 2 figures for you. We have the figure shown, and then this one is not drawn. It's just telling you that it's a 20-sided figure. So you need to find the interior angles of both figures. Alright, so for the first one, I see that it has 1, 2, 3, 4, 5, 6, 7, 8 sides. Okay, well, that means that n equals 8, right? And I can use my formula, n minus 2, so 8 minus 2 times 180. So 6 times 180, which is 1080. So the sum of these angles is 1080 degrees. The sum of all the interior angles, if I added up all these angles in here, it would be 1080 degrees. Alright, and for the 20-sided figure, well, n is 20. It told me how many sides it had. So that means 20 minus 2 times 180. So 18 times 180. Oh, here's a chance to use our perfect squares, because I can do 18 times 18. 18 squared is 324, but since that one's actually 180, I add the 0 on there. Okay, so a 20-sided figure has a sum of interior angles of 3,240 degrees. If you added up all the angles inside of a 20-sided figure, it would always equal 3,240. Okay, that's all you have to do to find angles. Now, there is one extra thing that you can do if it's a regular polygon. Okay, if it's irregular, then all you can do is find the sum, how much they all are together. Okay, but if it's a regular polygon, then there's another thing we can find. Okay, this is a regular pentagon because I see that all 5 sides are equal. Okay, and what that tells me is it tells me that also all 5 angles must be equal. Okay, so that's a key, because if I know that it's regular, not only are the sides equal, but so are the angles. Alright, so the first thing I need to do is the same whether it's regular or irregular, and that's find the sum. Okay, so it has 5 sides, so 5 minus 2 times 180. So that's 3 times 180. So the sum of the interior angles is 540 degrees. But that's not what I'm looking for this time. X is just one of these angles, not all of them. Okay? But all of them are equal. So if this one's X, well, that means that this one is X as well. And so is this one, and this one, and this one. All of them are X. So now I know what all of them are, and I know what they add up to be. So I can write an equation. So I have X plus X plus X plus X plus X equals 540. Okay, this is very similar to when we found the missing angles in the triangle. Okay, we know what they add up to, and we know what all of them are, so we can solve. Okay, well that's just 5x equals 140. So I can divide by 5, and I get that x equals 108 degrees. So each angle in this regular pentagon is 108 degrees. So you should be able to find sums of angles of any kind of polygon, and you should be able to find specific angles, like these, of all regular polygons.